I need aluminum oxide for refractory purposes, and I wanted to see a method shown in a form that I haven't seen much elsewhere. Instead of combining aluminum metal with a base or acid and neutralizing it, you can just use the aluminum as an electrode in electrolysis to yield aluminum hydroxide directly from its degradation. And since I only need it for refractory purposes, some impurities, like the electrolyte that I'm using, which is going to be Epsom salt, don't really matter because in the end it also yields a refractory as well. Here you see me making a solution of Epsom salt and water, and I used way too much Epsom salt here. You should only use like a few grams, like 10 grams for this size of container. And I'm going to put it in a steel pot, which is going to act as the cathode, and I'm going to put the aluminum ingot in it, which is going to act as the anode, and that's going to get degraded. And this is what the setup looks like. After a while, the solution started to turn yellow, and then eventually started to turn orange, and you can see these gross flakes being thrown everywhere in the solution. And this may have been a chromate being formed off the stainless steel having chromium in it, so I ended up just discarding this whole thing and trying again. For this new setup, I used 2 aluminum electrodes because I wanted to see if it was actually the stainless steel pot that was causing the solution to turn orange, and I used a little less Epsom salt this time, but you'll see it wasn't quite enough. After the electrolysis ran for about a day, I took out the solution and then I transferred it over to my little oven to dry it out. And here is the dried powder. There isn't very much of it, the reaction goes really slowly, and I believe there's a lot of impurity of magnesium hydroxide in it because of how much of the Epsom salt electrolyte I actually used. I believe that the Epsom salt actually gets prioritized first before the actual electrode starts degrading, so in a future run I actually dialed it way back. Then I heated it up to try to convert as much as the hydroxides to oxides as possible, and then I tried feeling the powder afterwards between my fingers to see if it felt like aluminum oxide, but I couldn't really tell, so I decided to see if the actual electrodes degraded at all, so I weighed it before, I did another run, and I weighed it after, and it ended up being the same weight. You can see all of the yellow flakes instead of what should be mostly white or gray from the aluminum hydroxide. So from this point I realized that I was using way too much Epsom salt. So after the ingot weighed the same, I dialed it way back to about 5 grams for this run to see if it would degrade at all. I used a towel as a barrier between the 2 electrodes, that way they could get really close to each other, because without all of the electrolyte that I was using originally, the current dropped down to about 100 milliamps at 30 volts. After letting the setup run for about 2 days, I was left with about 15.95 grams of powder, which did include a bunch of losses from drying it out because I just threw it in the pan to heat it up real quick instead of waiting to dry it out in the oven, and a lot splattered everywhere. But 15.95 grams isn't too terrible for 100 milliamps at 30 volts. And after checking the anode, you can visually see the surface degradation, such as the pitting going on. And in order to be sure that I actually had majority aluminum oxide, I wanted to test by making some rubies, but this didn't go very well because my brick that I was melting it in actually just melted with it. So once I get some more graphite, I can test it again. But the question remains of why would you even want to do this? Well, using the acid or base route and neutralizing it kinda takes a lot of labor, and where I live, hydrochloric acid is pretty expensive to do this. So this would also not only be a cheaper solution, but also an automated one in the sense that you can just leave it going for days and it would degrade the electrode over time.